This is a regular service. This is a microservice. Hey guys, and welcome to the show. I am so excited because today we have the one and only Razi back. Razi, what's up, buddy?
Hey, I'm doing great. Thanks for inviting me back. Looking forward to chatting with you guys.
Yeah, that's awesome, man. We're going to do microservices in Azure, correct?
Yes, we're going to be covering that today.
Okay. All right, so tell us a little bit about exactly what that is. What's a microservice?
So microservice is kind of like a loose term at this point in time. It depends who you ask, honestly. But in reality, I look at it as a combination of three things: people, process, and technology.
Okay.
Most likely today we're going to focus more on technology, like how you can deploy and host microservices on Azure. But in reality, I mean, you should look at it cohesively as a combination of these three things, because if you miss or if you neglect either one of these, probably you may not be able to succeed with your mission to get on microservices.
So I guess we all know what services are, right? Everybody that's run an OS knows what a service is. So what's the benefit of a microservice to the average IT person?
Well, I think that's a good question. So I think from the IT standpoint, I think the biggest benefit would be that the time to release, I think, and the time to maintain. When you have a traditional style services where, we can look at them and call them monolithic, the way you basically sustain them and update them is drastically different the way you do it in microservices. So that's a key distinguished factor between the two. If you look at the size of the services and the way you wanted to put them into production, compared to, for example, if you have a traditional application that have dependencies not necessarily spread across, there's a fundamental more work you are doing. So from like a little bit high level, when I look at the microservices, a good way to look into it is like, what are the key attributes that make them different from a traditional style development? And that's kind of like a borderline technology / like your practices, the way you actually build software. This is where the blend is. And I think this is where probably it's difficult to have a consistent definition of microservices. As I mentioned early on, that it's kind of a blend of multiple things together.
Yeah. Okay, so I kind of get that. So it sounds like we're saying that because these services are limited in scope, they're quicker to development and we can run them in containers in the cloud?
Yes, so containers is definitely a technology that resonates very well with the microservices because dependencies are right within the container. So the way I'm building or writing a code right now on my laptop, if I basically pass it over to you, all the dependencies are there. So by design, things should work. So there's no more like, hey, it's working on my laptop and now something breaks it.
Okay.
Yeah. Although something always breaks, but there's a different question.
Yeah. Okay. Great. Well, let's see the PowerPoints.
So let's just take a look at the history first. And I just put together the slide to take a quick look at what happened in 1990s, right? So these are the, let me just bring this down. So remember 90s?
Yeah.
Service-oriented architecture?
Yeah, and Ole, yeah.
OLA and all that. And
yeah.
So, I mean, the reality is that, and look at this page right here. It still exists, by the way. If I click on this, it will open up. This is from 1997. The point here I wanted to convey is that technologies, tools changes. So the only thing that basically important is to evolve and adopt the change. And I think Microsoft did a fantastic job, and we talk about it, different hosting options for microservices. We evolved on that drastically. So yeah, anything, just thought it would be interesting to share this. So what are microservices? There's a quote from Melvin Conway about like organizations that design a system will produce a design whose structure is a copy of organization's communication structure. So basically, the way the organization have teams interact with each other will have a direct correlation to what they will produce. And this is essentially reference in the Martin Fowler seminal blog entry that he did on the microservices many years back. And going back to the point, like how you look at the microservices, you need to look into it holistically from this side of the house too. So people, process, technology working together to provide you microservices. When it comes to technology, there are a few principles that you can look at when it comes to microservices. It's hard to have like a litmus test when it comes to microservices, but I would rather have these attributes. If they are there, then it's just better assurance that probably the design close to the microservices. So the first thing is these services, they are independent, and they're independent of technology. So you can have different services being developed in different technology stacks, completely independent technology stacks, most likely. You can deploy them independently, you can version them independently, and you can choose languages independently. So maybe there's one team working with Python and other team working with ASP.NET Core stack, and there's the other team working with completely different technology stack, and they should be able to have services that can be still work together. And that's an important area to understand, because traditionally, both on the Microsoft side, Microsoft technology side, we have Microsoft Stack, especially with .NET, we have developers working with Microsoft like languages like C#, ADO.NET, Entity Framework, SQL, all the whole shebang. But if you have another vertical in the same organization working with, let's say, open source technologies, historically it was a little bit difficult for these two teams to cross-pollinate. With microservices, things changed drastically on that front. So you will see that throughout this talk, when we look at microservices in Azure, we try to bring or enable customers to work throughout the technology landscape. It's not like just .NET or one particular technology stack. The other thing that is important to call out is the automation. And really automation here, if you see here, this circle I draw or try to draw is basically like a DevOps. So you wanted to make sure that you have a very streamlined way of putting things into production. They should be automated. There shouldn't be like a big bang releases, or there shouldn't be any surprise or ceremonial style releases. So the quicker you put things into production, you test them out and get the feedback back to the development team, the better it is. And that typically means shorter release time. So release to production can be ideally maybe weekly or less, but it shouldn't be like twice a year, which we all know not necessarily great thing. Other things are from like fail-safe standpoint. These services fail predictably, so no single service should bring the system down. And that's a critical piece. I mean, literally, if I have to pick one thing, this is one of the most important item. Like if you look at the system holistically, and if you just probably take one of the services out, the entire system should be able to at least function in a predictable way. Even if it's not 100% working, it should be able to fail safely. And most likely you wanted to have automatic recovery blend in there too. And finally, we have the encapsulation piece, which is basically these services are really nimble, small, so they're single responsibility. You don't want it to have one service doing 5 things. And the reason really is that the more you're going to, like if you bulk up a service with multiple responsibilities, then really it's not a single service anymore. So that's an important thing to understand. And you also don't want it to expose the how part. What is important for other services to know, like what that service is achieving, how it's being implemented, is it X technology stack versus Y? You don't really care. The agreement is going to be more on like the what part and some other aspects, not essentially like what technology and how it's been done. So this is a very high level sort of like an introduction to the microservice principles. Now, when you implement these in reality, you need to follow some patterns. These are some of the common patterns. There are much more than that. And we do have like a workshop and chalk talks that talks more about these, but just to touch base on a few of these. When these services went live in production, you definitely want them to be discoverable, and there are different patterns for that. And remember, we're talking about small, independent, discrete services, so it's challenging to for the client to go and discover them. So you need to follow certain patterns on that. So there's a server-side discovery pattern, there's a client-side discovery pattern, and depending on your use case scenario, you may want to choose one of them. There's a service registry pattern, there's an API gateway. So there's a lot of literature around in the back that you need to sort of like ramp up when you start looking into microservices. I won't say that you need to know it all, but you probably wanted to have just enough information to go out before you start working and developing these microservices style applications. So with that, let's take a look into what options we provide as Microsoft in Azure. And I sort of like sum it up into this slide here. And if you notice on the left-hand side, we have the VM scale sets, which is really kind of lowest common denominator when it comes to infrastructure for us. These are elastic and declarative, so you can create an ARM template and you can have a basic unit of deployment right there. Now, typically when you think about microservices, VM scale set may not come into mind, and the reality is that if you use VM scale set as is, you can deploy applications over there, you can scale them. However, you still have an infrastructure piece that you're managing. So when we work with customers, at least my experience is that they are like it depends on the maturity level of the customer and depending on their existing workloads. If they wanted to bring it to Azure and they are not necessarily looking into greenfield, they have some legacy applications which they may or may not wanted to redesign, then we still wanted to make sure that we have a path forward for them. But as you go towards the right, you will see that what I have over here, let me just move it a little bit here, is the hyper scale. And the first thing that you see there is the Azure Container Service. And Azure Container Service is essentially a hosting platform that we provide to host open source, high density container-based platforms. And this is really, we're agnostic there of products. We choose literally what's resonating with the market right now. So Swarm, DCOS, and Kubernetes are, at the time of this recording, are the leading contenders. So we support them. And we'll talk about that later. So I'm not going to go in detail, but today, if you wanted to go and create a deploy your containers in Azure Container Service is a great option. Now, high density probably needs a little bit of a explanation. So high density really means that if you have an application, let's say running full-fledged existing on-premises application, and you wanted to somehow craft it and put it into container, container is a platform that can allow you to do that, because functionally you can look at it from, well, I have a VM, and the closest thing that comes to the VM is a container. Now, I think it's fair to say it's debatable how you wanted to create a microservice, and I don't think there's one answer, but the point here is that if you have existing set of applications running today, maybe let's say .NET 3.5 applications, and you eventually wanted to put them and scale them heavily, then it may make sense to put them into container. Then as we go towards the right, you will see we also have the open source PaaS platform. So Cloud Foundry is, Pivotal Cloud Foundry is what we provide to be hosted. So you can use that. Mainly like if you are a Java shop, customers who are working with Java-based applications gravitate towards that. So we wanted to make sure that if they wanted to run their solutions and they're creating microservices based on that, then that's one option for them. And then we have the app service. So app service has been around for a long time. I think even before Azure Container Service and Service Fabric. We have App Services platform, and App Services is quite a holistic platform. So we provide customers the ability to create web-based applications, mobile, and also serverless. So serverless is with the Azure functions. You don't really need you don't need to be aware of a VM in the back, and you don't have to care about that. It's basically you write your logic inside the function, and then you can access it in certain ways. We recently, I believe, late in 2016, added support for Docker containers within the app service. So, and I will show you the demo for that. So that's a big move forward, because now you have various platforms to host containers. You can basically host it yourself if you want. Create a VM scale set. You can host it with the Azure Container Service if you want. You have multiple options there to choose from, like which orchestration platform you wanted to use. Or you can actually use App Service. And then from there, you can actually have the Docker container support. And finally, we have our own premium platform, the Azure Service Fabric. Now, Azure Service Fabric is many things. There are slides next, so I'm not going to go in detail here, but it's an orchestrator. It allows you to write these hyper-scale, and I mean really, really hyper-scale microservices style applications. It provides you basically a programming model to do that, and you can choose based on your requirement, like which one going to be a good fit. It also have this option that if you choose not to use a programming model, rather than bring your own executable, like it literally can be like a console application, if you want to put it like that, or it can be a container, because it's executable at the end of the day that hosts a container, and you can use Service Fabric purely as an orchestrator platform. So it's a pretty flexible service in that sense. Yeah. So another area that you will find out when it comes to microservices being talked about is orchestration. And just to clarify here, that orchestration is not necessarily means containers. Containers are essentially unit of repeatable deployment, and one of the main benefit is that all the dependencies are within the container. So that's a big problem solver in the technology industry, right? And they also provide you a security and isolation boundary. Especially with the Windows containers, we added support for the Hyper-V containers that give you a higher degree of assurance when it comes to the isolation.
Yeah.
Now, the orchestration is something else. Orchestration really means that it does a lot of things underneath the umbrella of orchestration. So orchestrator will do automatic failover, it will do upgrades, it will do state management, it will do constraints. Like, for example, you can tell orchestrator that I do not want this particular container to go beyond, let's say, 50% of the CPU isolation, or I wanted to put a threshold on I/O and things like that. They can also do the health checks. So there's an entire market around orchestrators. Microsoft has their own Azure Service Fabric that provides orchestration, and there are some other third-party orchestration out there. So because most of the time the orchestrators will be working with containers, sometimes there is this sort of like ambiguity, like where actually, are they together, or can you have an orchestrator without a container? The answer is yes. Orchestrator can work without the containers too. So I just wanted to call it out there for audience to understand that. So now let's talk a little bit about the Azure Service Fabric. And what I did here is that I don't want this to be like a death by PowerPoint. So there's a TLDR thing right there that talks about what it is in one line, and then we talk about a little bit details. So Azure Service Fabric in a nutshell is an orchestrator, is a microservices programming, provides a microservices programming model. And it also provides ability to host the guest executables. And if you put it together, this is like a pretty flexible platform. In fact, internally, we've been using it for many years. So last year in 2016 at Build, we make it it become GA'd. Before that was in a preview. But way before that, we've been using it internally. So there's just few services that that are built on top of the Azure Service Fabric. So we have the core infrastructure, paying Cortana, Event Hubs, Document DB, SQL. It's a lot of application services out there. When it comes to the Service Fabric, there are a couple of things to understand. Based on the use case scenario, you can use Azure Service Fabric in different ways. So one way to look into it is that you can create microservices using the programming model provided by the Service Fabric. And programming model means really, in this sense, it really means that you will go ahead and choose, do you want it to have a stateless service or a stateful service. When we talk about the stateful service, do you want the Azure Service Fabric to provide you means to manage the state? So you use the, let's say, reliable collections for managing the state. You can use the actor model. That's very popular when it comes to scenarios like IoT or connected devices because they're essentially actors interacting with each other. But what happens if you do not want it to, for some reason, maybe technical, maybe some business reason, you don't want to invest upfront and go towards that route, then you can use Azure Service Fabric as a orchestrator. And in that sense, what really going to happen, that it will allow you a platform to basically host and run the guest executable. Now, there won't be any like a programming model, the Service Fabric programming model involved in that. You're not going to get probably the benefit of managing states that way, but you do get benefit what Orchestrator provides you. You get all the feature set there. So in that case, you're basically using it just merely as an orchestration platform, but that can be very very handy because if you look at it, Service Fabric as an orchestrator can support running Docker, Windows, and Hyper-V containers. And just to make things even more interesting, you can have Service Fabric running containers. So basically, you're hosting it as a guest executable. And then there's one option. The other option is that you can have a container, and container can run Service Fabric inside it. And you will probably ask, like, why you want to do that? Well, the reason goes back to the fact that when Service Fabric, when you write Service Fabric based microservices, these services are deployed as a process. So every service that you're writing essentially is a single process. When you build applications like in a container provide you a view that's like a own operating system in it. So it's a fundamental difference right there. So when you deploy services using a Service Fabric programming model, the microservices, then every service is like a process, and they basically share the operating system in that sense. When it comes to container, every container has its own view of the operating system. So this is sort of like a different in the density right there. So you can choose between the two, and the reality is that, based on my experience working with the customers, it's a blend of these things together. It's not like one or another. It's like, well, for these scenarios you wanted to use this, for these scenarios you wanted to use this type of a blend of these two together. So it's interesting how I wanted to put it. Yeah, so let's talk about the Azure Container Service. It's the easiest way to describe it is like it provides you hosting option for the open source orchestration and scheduling tools that are pretty much leading the market today. And the reason we are really not here to pick the winner. This is really based on the customer feedback, and whatever tools are resonating in the market with the customers, we are basically supporting them. The easiest way to look at it probably is to see what we have there. We have Docker Swarm on the extreme left. Of course, this is coming from the Docker, the company. And you can use Docker Swarm basically to provide clustering for the native Docker containers. Uh, the the Swarm has evolved a lot in the last 2 to 3 years. So basically, there are customers who are invested in Docker, and they are familiar with Docker Swarm. So historically, they've been using it. So we want to make sure that if you want to put your containers out there and you want to scale them in Azure, then Azure Container Service provides you support for that. Another one, which is I think the last 18 months or so, been getting a lot of traction, is the Kubernetes. Kubernetes was originally came out of Google, and they open source it. And what's happening on the Kubernetes front is that Kubernetes initially it was running on Linux, and it still do. We support that in Azure Container Service. There's another effort going on to bring Kubernetes to Windows, and there was a release in December 2016 where the first alpha release, which supports Kubernetes on Windows natively. It's very early right now, so there are a lot of features that are not there. So in terms of parity between what you get when you have a Kubernetes, the original Kubernetes versus the one on Windows, but the roadmap is definitely there. So there's a continuing area of investment for Microsoft. So if you wanted to use that, then we also provide support for that. Then another very actually battle-tested product out there is DCOS. This is from the Apache Foundation, and they have they have a product called Marathon that you can use to basically do the orchestration. And just to give everyone an idea here, with the Marathon, you can basically do scheduling not only for the Docker containers, you can do for other type of applications too. So because of the popularity, I believe the way that Docker provide the API or the containers, containers become synonymous with Docker. But I think it's important to call out that if you're working with microservices, then and you choose to use some other technology, then you can actually host them on Marathon too. They also have the REST-based API, so you can communicate with Marathon. And because it's REST-based, it's pretty much technology agnostic at that point in time. So we'll take a look at the demo for one of these, like how you can put the container out there in the Azure Container Service. So I think the first demo, what we'll do is that we'll go ahead and create a container and use it to deploy on a different Azure hosting platforms. So I will just quickly check the Docker is there, and the container that we'll create is based on ASP.NET Core. So I have the test application ready. If you want to do it on your end, you can do the human and then use that tool to create this basic project. One thing that this project provide you is the Docker file built in. So if we take a look at the Docker file here real quick, you will see that it has all the basic information here. So if you opening the port 5000, which is the default, and then it will make sure that it compiles. So the way we do it is that I already have it compiled, like build. So if I do the Docker images, I have the ASP core hello world here. So I can go and run it. So do Docker run, and we do the port mapping here to 5000 and ASP core hello world. And okay, so now we're going to go and run this. So I will map the port because I'm using 5000 internal to the container, and we will make sure the name of the container is there. And basically, it should go and run this.
Looks like it started.
Yeah, so if we go here and localhost and we map it to, and here we go. So we have the hello world right here. And well, it's not very fancy. I get that, but it's working. That's the whole idea.
Yeah,
Now,
yeah.
couple of things there, right? So we wanted to make sure that we put this out to some place where Azure environment can access it, because eventually we wanted to run this outside my laptop, right? That would be better. So one way to do it is the way that I choose it for this demo is put it on the Docker Hub. It's a public repo. So I have my own account here and I put it over here. So what we basically did here is we created a container, because another container, I call it 2, because we wanted to put it out there in the public repo, and it's now ready to be pushed.
Okay.
So actually it will be a push command here, and we'll go ahead and.
So you're taking the container that's local and pushing it up onto the site, the storage site for containers.
Yes. So what I'm doing over here, just to remind everyone here, that I'm trying to put it right here.
Yeah.
Which is the public repo. If you have a private repo that you can actually host on Azure or somewhere else, you will use the same command. It's just going to connect to a different repo.
Okay.
And this time, hopefully, it should go. Yeah. So you start uploading, and hopefully within a few minutes, it should be done. So you can see it's done. And if you go and refresh this, we have the Hello World 2 here. So here we go.
Yep.
So now what we'll do is that we will try to use this outside my laptop. So the first service I will use is the app service, and app service recently started supporting the Docker containers. And the way you do it is you create a, let me show you. So you basically go and start creating a new service, and you can say app service Linux, and you can search for it. And right now it's in preview, so may or may not be 100% giving it 100% results all the time. So you will go and create like an app service as you normally do, and rather than like waiting for this to be done completely, I have one already created. So if I go back here and go with the don't ask me why I created such a brutal name for the resource group. Basically, what we have is a demo container, a named demo container. This is the app service that we have, and if you go into the app settings, actually in the Docker container, it will allow you to select the image. So you will see that there are 3 options here. They have the built-in option. So if you choose the built-in, there's a few runtime stack that they support. And they have images that drive from these stacks. I actually wanted to use the one that I developed. So it's a Docker Hub. It can be private or it can be a public registry. And then we have the you can have it also on the private registry outside the Docker Hub. So in this case, we have let's say the Hello World 2 here, and we can save it, and it will essentially connect to the public repo and then try to get the image from that. Now, right now, because it's public, it doesn't need any authentication, but otherwise you have to provide the credentials. One thing quickly to mention here is that if your container need to have a mapping, then it has to be defined over here, because again, this is running in the app service environment, which needs the knowledge that the mapping of the ports need to happen. So it seems like that is done. So it's done right here, and the easiest way to test it out is that we go back here, and we have this URL here. If you go and browse it, we will see the hello world right here. So basically, if you notice the URL here, this is the web app within the app service hosting our container, basically running it. So this is one option that we have to run containers on the app services.
Okay. That's cool.
Oh yeah, so this is in previews, is recently been added. The other demo that I want to show you is same container, but this time we will use the container service. Now the container service is the Azure Container Service. As we saw earlier, that it's a more holistic hosting platform, so it provides you different tools to be hosted by this service. So what this means is that when you go and create, if you go and type in Azure Container Service here, you will notice that it's you can create it, and the options going to be more broader. So let me just choose a name here, and it actually needs the public key here. So you need to create the private public key pair. I basically have it created before, so I'm not going to create it here. I will just basically wanted to show you that how to create a new container service. But if you go back and take a look at the one that I have, if I go in, it basically give you option to either use the Docker Swarm, Kubernetes, and DCOS, and you can select between the three. I choose the Docker Swarm, and Docker Swarm basically have concept of these like agents and the agent pools. And in this case, I basically have one agent running will run my container, and basically we have this sort of like a front for that will that we can actually connect and see our container running. How do you actually do that? It's a little bit more involved, so I'm not going to go in complete detail, but what I can show you is I'm basically SSH into that particular agent. So this is the agent which actually is running. Let me go back. This is actually a VM, so I can do the SSH to it, and within that our container is running. So if I go back here, you will notice that the container is running over here. The thing to realize here is that unlike the app service, in this case you're using a swarm to manage the cluster of your containers. So you're not necessarily going to do it yourself. So there's certain benefits, because in this case you can scale and provide certain type of information to Swarm, and then it will able to do it for you. So but in a nutshell, if you go back here, that really means that if we go ahead and create a new one here, let's just click this one, and so this is the address right here, and this will give you the hello world, the same hello world that we saw earlier on, because the container is the same Docker file and the code. So this is one way of running like a container within the ACS, in this case using Swarm. You can use Kubernetes, you can use DCOS too. You still need to set it up upfront. So the different ways to set it up, the easiest way I found is that you can go to the Azure Container Service page, and then they provide you not only the educational piece, they also provide you this this great ARM template to actually build these entire to build the entire service. So if you go here, you will notice that they talk about these options, and this gets updated quite often. So there's an option right here, deploy the cluster. In this case, is it will walk you through basically step by step for all the deals. So like how to put the SSH keys. So this is a good way to start. If you wanted to fully automate it, you don't want to use the Azure portal for that, you can also do that. And for that, basically you need to work through the ARM template. And one way to do it is by going to the Azure Container Service Git ARM. And this will give you the ARM template that is needed. So it's the same article here, and they have the different type of there are different type of articles here provide you supporting like how you can use the ARM template for that. So there's the Azure Container Service piece, and finally let's take a look at the Service Fabric. So for the Service Fabric, you can do multiple things with Service Fabric. So what I'm doing right now, I'm in a VM with the local Service Fabric environment installed, and I also created let me go back, a cluster in Azure. So if you go back to the, actually let's go back here to the Service Fabric, and this is the landing, sort of like a page in Azure for the Service Fabric. And you will notice that with the Service Fabric, we create the nodes, and it will basically going to manage it for you. What I have here installed is an application, and the easiest way to look into it is going to this dashboard, and it gives you basically a view like into your entire Service Fabric cluster, like what's going on. But without going into too much detail, I think the important point here is that you can create a microservice, stateful, stateless, and deploy it over here. If you wanted to bring your guest executable like a container, you can do that. For this demo, actually, I choose to create the same like a Hello World ASP.NET Core application, but as a stateless service. So for that, the way you do it is you go in, you create a new project, and you select the Fabric, and then there are different options here. ASP.NET Core is right now is in preview at the time of this recording. It will be hopefully soon will be GA'd. Then we have the guest executable. This is where you wanted to, if you wanted to host container or any executable for that matter. Literally, I can have a console application. You can put it over here. Then we have the stateless web API. This is your like traditional ASP.NET web API. You can with the Oven component there. The actor service that I briefly mentioned early on, like for like connected system IoT scenarios, usually resonate with them. And then we have the stateful service with the which is basically going to provide you the reliability. So the different ways to create microservices here, and I think that's the reason why we for the scenarios we're really looking for that hyperscale feature set. We want customers to go in and look into and evaluate this first, like what would be a good fit for them. For this demo, I created the ASP.NET Core application, and actually, let me just go ahead and open it somewhere. So right here, and what we have over here, if I go and run this as is, it's essentially the ASP.NET Core running on Service Fabric cluster. And the easiest way to test it out locally is set up just simply a basic a Service Fabric cluster. And what I have over here is a 5-node cluster, because not everyone may have access at the time of development to the Azure cluster. So if you go back now and look at this localhost 8182 endpoint, we are running our ASP.NET Core application right here. A few things to call out here. You can actually take this as is, and you can, it actually comes with a PowerShell script to deploy it. So you can do the deployment within the Visual Studio, or you can simply use the PowerShell and take the package and use some other machine to automate it. This is completely possible. You can also have the advanced like a DevOps scenarios where you can have the integration with a VSO and then have a build automated release and things like that. The way that I did it for this demo is I went in and I choose the publish option here, and this is the basically my connection endpoint. And the reason why I know this because this is essentially this cluster right here. So if we go and publish this, then it will go ahead and package it if it's not already packaged. All the behind the scenes stuff, a few minutes just to save time here. All right, so we basically I deployed it already there. I don't want to necessarily take those few minutes for us to wait here and see how it get deployed. But essentially, it's going to package it up and deploy it. And if I go to this endpoint here and run this is essentially the same hello world, and it's running right here in the Azure Service Fabric cluster. One minor thing I wanted to call out here that I did is, apart from clicking on that publish button, is I went to the load balancer, and you wanted to make sure that the incoming request can be routed to a proper port internally.
Sure.
Because remember, internally the service is running on a different port. In this case, it's running on the port 8182. So you need to basically have some sort of rule telling the load balancer that, hey, if the request is coming on port 80, map it to the port 8182. So you have to do this step. When you do it through the ARM template, or if you do it through the PowerShell, you can automate it. But just if you're doing by hand, you have to do it. So that's pretty much conclude the demo piece.
Cool. Yeah, that was actually pretty neat. I think this is very interesting. By the way, what's your shirt say?
Oh, my shirt, it says I ate all pie, and it was delicious.
Yeah.
You got it.
I got the pie, and it was delicious part. I figured that the first one was 8, or that there was an 8 in there somewhere.
Yeah, I think the submission is also,
Cool deal. Well, listen, man, thanks for doing this for us. Is there a place that people can go to get more information?
Yeah, sure. So I do wanted to call out here, and I'm basically, if you look at the PowerPoint slide here, PSFD provides different type of services around microservices. So we have the assessment that basically goes from like few days to few weeks, depending on the customer, to help them out, assess their maturity level on the microservices. Some customer wanted to have this sort of like a early look into microservices, so we work with them and analyze like how much work it's going to be for them, provide the roadmap and things like that. Also doing a lot of proof of concepts type work and the pilot, which is basically like, okay, we know what we probably want. Can you just give us sort of like a view into it and build something? So we usually work with their teams and help them out. That's another thing that is very good for the customers, especially who are looking into moving into cloud and wanted to evaluate Azure, hosting options for microservices. We also have a pretty good degree of educational related items. So we have workshop and the chalk talks. 2 workshops that are available today is one is building microservices using containers. It's a 3-day workshop. It basically starts from the premise that, well, let's talk about containers, the entire landscape, then is grow more into like building some microservices and deploying them into the Azure cloud. I have to call out that if customers are predominantly working towards like having microservices first on premises, is still very relevant. And we do have hands-on labs, so you basically get some sort of like a hands-on experience with it. We also have a 3-day workshop on Azure Service Fabric programming models and how to create like microservices using Service Fabric. This is again totally focused on microservices, particularly with the Service Fabric piece, and it also have hands-on labs. There are other chalk talks that we also have, which are like 60 to 90 minute interval, ranging from like, hey, I don't know anything about microservices to we tried a little bit, let's talk about how to put them into operations and what are the challenges. So sure, and I will share these data sheets with you too.
Well, man, that was awesome. Thanks for doing that for us.
Thanks, Lex and guys. Thanks for having me.
Yeah, anytime. And happily, we'll invite you back. I love doing these shows with you. This one was pretty deep. I think that developers will get a lot out of this, and hopefully somebody that's considering containers and has watched our previous containers video will get a lot out of this one. So pretty interesting stuff.
It is, and I think the areas that we didn't really have time to touch upon in today's talk is for example, the DevOps piece. How do you operationalize it? from Visual Studio all the way down into production, like how things work, how how you wanted to look into some of the pieces running in production, how do the monitoring, what tools we have over there. So yeah, I mean, it's probably like bits of pieces that goes with that.
Yeah. Well, that sounds like another show to me.
Yeah, absolutely. Happy to be back and talk about it.
Okay. All right. Well, listen, thank you so much for doing this for us. And guys, that's your Taste of Premiere.